All right. Hello, everybody. I think we are currently live, hopefully. Welcome to the stream. Actually, my camera's over here. I should probably be looking over here. This stream's going to be a little bit different than most of my other streams. Most of my streams are either chaos modeling streams or something related to computer graphics. And while this is slightly related to Blender, it's also completely on the opposite end of the field. So to put things into perspective here, I basically built a microprocessor and a full-on computer system in Blender's node editor. Actually, I should rephrase that. I'm in the process of doing so. Currently, I have a full instruction set architecture and microarchitecture built, and I'm currently working on making sure that that microarchitecture works so I can run actual code on it. Basically, I'll be able to run code in a computer that I built in Blender. That's the end goal here. So anyway, thank you for complimenting my lighting, Mr. Wayne. I appreciate that. Anyway, just to check, are my audio levels fine? I'm pretty sure they were. I checked them pretty well before stream. Hopefully the music's not too loud. If anything needs to be tweaked, send it down in chat, or I guess chat's gonna be over there, and let me know. Otherwise, I'm not gonna know. What else do I have to say? So in this video specifically, I'm going to be writing the assembler for this computer. Now, an assembler is basically part of the software compilation process, not progress. So when people write code, they write in a high-level language. So that's something like C, Java, Python, all of these very high-level languages, including like C# would be another one, or C++. They write in these high-level languages, and then they feed it through what's called a compiler. And a compiler takes that very high-level code, basically mixes it around, and compresses it into a more low-level and more fundamental language called assembly. Now, assembly, actually, I guess I shouldn't talk for C# and Java, because those work a little bit differently. But most languages, we'll use C as an example here, will, when they compile, turn into a low-level assembly language. And then from that assembly language, they're put through what's called an assembler, which turns them into machine code, which is basically the actual binary stuff that a computer can read. It's literal ones and zeros that when fed through a microprocessor can be read and executed as code. And that's basically how that pipeline works. You start with a high-level program such as like, or a high-level programming language such as C or something, then it gets compiled down to assembly, which then gets assembled into, sorry, I'm laughing because I just saw somebody from my school in the chat. Hi, Seth. Seth, I'm doing this because I'm crazy, and I built a computer in Blender because I can, and that's how it works out. But anyway, that's how this works, right? It goes through that pipeline, and right now what I'm going to be doing in this stream is I'm just going to be playing around with Python, trying to build an assembler, which I've never built an assembler before, to actually create an assembler for this entire instruction set architecture that I designed. So, let's go ahead and hop into it here. I'm going to start by showing you guys the actual microprocessor in action first. As you can see, I still haven't set up Blender properly because I just downloaded the new version. But let's go ahead and get started. Oh, I have a green screen. Actually, I should probably switch my camera over so you guys can see my screen. And we don't need this green screen down here at all. All right, so let's go and show you guys BARNDLES. By the way, the entire project is named BARNDLES. The reason for that being that there's a person in my Discord server named BARNDLES, and when I asked what I should name it, he said, name it BARNDLES. So I named it BARNDLES. Anyway, so here is what BARNDLES actually looks like. Let me get rid of this panel over here. Actually, we can leave that out. So what you're looking at is the actual microprocessor component of BARNDLES. This is entirely forward processing logic, and if you're familiar with computer architecture, you know that a processor works in a few different phases. First, it has to fetch an instruction. This basically means getting the next line of code from memory. Then it has to look at that instruction and run it through what's called the decode cycle, where that instruction is, it's determined what exactly that instruction is and what configurations the processor needs to be in order to actually execute that instruction. In the decode phase, it also kind of figures out which numbers it should be pulling, whether they should be pulling from memory or from data within the, or from registers within the actual CPU itself or the processor itself. Then after it gets decoded, it gets run through the execute cycle, which actually executes whatever operation on the code, for example, 1 + 1, and then it outputs a 2, which is then written back to memory or to the register file after that. So what we can actually see here is that exact high-level architecture portrayed using nodes. So here we have the fetch phase, which isn't quite complete yet, but I'll explain why that isn't quite complete in a little bit here. We have the decode phase, which will decode instructions and tell the rest of the system what it needs to do. We have the execute phase, which will actually execute the code and make something happen. And of course, then we have the memory and the write back phase, where these data are written back to some form of memory. Now, with that kind of covered, I'm gonna go ahead and look at chat and answer some of your questions, because I'm seeing a lot of questions popping up. So Mr. Wayne said, are you also making your own instruction set? I am, in fact, making my own instruction set. In fact, let me show you guys here. Barndles, the Barndles ISA. I'm getting text now. I'm gonna put my phone down over here. By the way, sorry if you can hear some stuff going on outside. I have my window open because my room is about 80 degrees. But anyway, I am developing an entire formally documented instruction set architecture, which you can see here with all of the different instructions and how memory is mapped. And we can talk about all this later on as we go. Let me show you guys the Excel document as well, because this is kind of neat. So these are actually all the instructions that we can run. And so this kind of gives you an idea of what assembly actually looks like. This is what assembly code looks like right here. These are individual instructions. So if we say add, RD, RM, RN, we can explain what those are later. But these are the actual instructions that we're going to be executing. These are lines of code, basically, each one of these. And these are every single possible combination of code that my Barndles architecture supports. What else is on here? Okay. Do we have any other questions? You know, Blender's really powerful when you can make your own computer in it. Did my Wi-Fi? Okay. I think the stream just dropped for a second there. Yeah. Anyway, hopefully it's back up now. That was kind of annoying. Let me know in chat if you guys can see my stream again. It just said it disconnected. Oh, people are saying yes, I think. And then 1xh said, will you upload the finished stream? I've got to go. Yeah, this will all be uploaded. Just a note though, I never put them on like my main channel. So if you want to see where these streams are, you're going to have to look on my channel. If you go to playlists, there's a playlist with all my live streams in it. That's where it's going to be. It's not going to be, you know, in my main video feed with all my other videos. Barndle says, Grant, join voice chat, coward. Okay, we're going to hop in stream private with Barndles or Bungalow here. Hello, Barndles.
Hello, Grant.
Let me know, guys, in chat if you can hear Barndles all right. Hopefully you can.
I hope so. I can turn down gain if it's like super staticky.
You sound good to me right now, but
Okay.
hopefully he's not overpowering me, and hopefully, oh wait, actually, you know what? I bet they can't hear you because I think I have
Oh, that's good.
desktop audio turned off. Okay, now you might be able to hear Barndles.
Can you hear Barndles?
Can you hear Barndles? We gotta know, chat. Can you hear Barndles?
Can you hear
He's too
Barndles?
quiet. He is quiet. Okay, everybody's saying you're quiet.
Okay, I
Okay,
can
I can
just...
just-
No,
flag
no,
my
it's
game.
fine. I got balance things over here. Let me change you.
Really?
Okay. What about now? How is Barndles now? Barndles,
This is
speak.
better. I'm speaking.
He is speaking. Round two.
This is me when I'm speaking.
He's overpowered by the music. Okay, let me just like crank you up to normal. Can you say something again?
No.
Okay. He is completely... Oh, now we're having echo because I don't have headphones on. Rats.
Oh, well, that's on you.
Yeah, that's on me. I'll throw a pair of headphones on. We love live stream technicalities. This is why I don't like doing live streams, but fair enough. Okay, hopefully y'all can hear him okay now. And he's not, like, super quiet. Box says perfect. That works, but echo. Yeah. Okay. Well, you shouldn't be able to hear his echo anymore now that I got headphones on, so we don't have to worry about that.
Nice.
Alright. Barndle sounds like a higher being with all the echo, says Gabe. That cracks me up. Alright, so anyway, back to where we were. This is the instruction set architecture. These are all the instructions that I'm going to have to implement with my actual assembler. Now, the entire thing that I'm going to be doing here is basically writing this assembler in Python and somehow doing that. So, I don't know how I'm gonna go about that because I haven't written anything in Python in a hot minute, but I don't know.
Well, you'll figure it out.
I guess I will have to figure
I
it out
hope.
one time. Zohib says Barndles is a higher being.
Yes. This guy gets it.
So anyway, just a little bit more to kind of explain how Barndles works here.
Yeah.
Let's see here. Oh yeah, this is, by the
How
way,
do I
we're
work?
you're listening to Barndles as in Barndles the person, but then we're working on Barndles as in Barndles the computer. So that might get a little bit confusing.
Nah, it won't. No one will be confused at all.
Should I just refer to you as Bungalow?
No.
Bungalow.
Keep it Barndles. I want to
Okay.
see how many people get lost.
All right, we're gonna keep it Barndles and just cause mass anarchy here.
Yes.
This is the folder I wanted to go into. Another thing that you guys should note about Barndles is that the way that Barndles memory architecture works, this is so weird talking with you in the chat. Barndles memory architecture works is, well, you see, here's the issue. In an actual node editor setup, it's all forward processing, which means that you can't actually create any sort of memory in it. Because memory requires what's called a feedback loop, where a circuit literally comes down and ties to itself back where it started, basically. So its output is tied to its input. And because we can't create that using Blender's node editor, that kind of puts us at a disadvantage. We can't create memory in the Barndles node editor, or in the Blender node editor. So what we instead have to do is store memory outside of it, somewhere outside. And in this case, I decided that I was going to use an image as the actual memory for Barndles. So everything that you see that's running through Barndles is actually stored in a 64 by 64 pixel image, which looks a little bit like this, featuring some beautiful artwork by Boombox. It's gonna be really blurred when we open this up in Blender. Actually, I guess I can just show you in Blender. This is the memory image right here. If we switch into the image editor, pull up the test memory. So this is the memory image, which basically means each of these pixels either contains some sort of number, so like 100 or 500 or 600 or 2 billion, I don't know, actually 2 billion is too large, or it contains some sort of instruction, which was placed there by my assembler. Unfortunately, my assembler doesn't work yet though, so we don't have any instructions, and that's why I need to write this assembler so I can start testing the actual code running on Barndles here. So anyway, that's what we're doing in this video, is trying to figure out how in the world to write an assembler using
Me.
Python. No, not using you. An assembler for you.
It is me.
It is you? You are you.
I am the assembler.
Okay. So just gonna see if anything else is going on here. Box says you're responsible if I go crazy trying to understand this. Hey, if you go crazy trying to understand this, you'll be a much better computer engineer. That's for sure. Why did you decide to use shader nodes instead of compositor nodes? Actually, no reason at all. But I like shaders better, and I don't like compositor nodes because they weird me out, and it takes a really oddly long amount of time for them to process. Who else? And shaders also have a lot more math functions. Gabe is right in that regard. Hi, will you make something in the future similar to CGC Weekly? Probably not. I've kind of moved on from the whole Blender tutorial thing, not gonna lie. I am a full-time student now, and that requires the majority of my attention, so I tend to put more work towards that, and I don't really have much time for doing tutorials and stuff like that, especially weekly tutorials. But I'm glad you liked CGC Weekly, at least I'm assuming you did, considering you're asking if I'd do something like it again. Alex says, I don't even understand what you're making, but I'm pretending to anyway. Just pretend, it's a computer in Blender, that's what it is, and right now we're writing the thing that makes the code runnable on the computer. Straightforward. Simplest way I can explain that.
Cool.
He's building a computer with math. Basically, Gabe. Gabe's on top of it.
Yeah.
Alright, so let's start. I have a PyCharm project loaded up here, which is basically just a Python project. PyCharm is just the IDE I'm working in. So the idea is I want to do this all in one script. Actually, I could probably code this in Blender, but I don't really feel like doing that right now. I could...
You know, the easy method.
Yeah, I could do this in multiple files. I think I'm just gonna try and turn it into a script, which might be dangerous. Actually, now that I think about it. I'll have to think about the modularization of code as I do this. But assembler.py for now is just going to be the script that I run that will assemble whatever code I have. And this main.s file is actually I didn't mean to have stuff in here, is going to be where I'm actually going to be writing my assembly that I'm then going to compile. So anyway, let's go ahead and get started. I think the first thing I'm going to do is write a really simple assembly program using BARNDLES assembly. So let me pull up my instruction set here. I'm pretty sure it's very closely or very loosely related to ARM assembly, because that's the instruction set architecture I'm most familiar with is ARM. But that doesn't mean that we can't do something in the meantime. One caveat before we get started here is that it's important to note that while most of these instructions are working, currently jumps don't work. So if I wanted to basically run code and then jump up to another section of code, that's not going to work because I haven't gotten around to implementing that yet, but everything else should work. Or jumps or branches. Wait, these headphones keep getting curled up. Untold Journey asks, just out of curiosity, what are you studying for school? I'm studying computer engineering. Bet you wouldn't have guessed that, considering I'm building a computer. But yeah, I'm a computer engineering student, sophomore at the Milwaukee School of Engineering. So, of course, I'm home now because of coronavirus, but yeah, let's go ahead and get started here. So, main.s, what do I want to write a program to do? Let's think of something really simple.
Spell my name.
Spell your name. Oh,
Yes.
You know what? We could do ASCII.
Nice. Also, I'll be right back. I gotta take the trash out.
Okay, have fun. That's not a bad idea to spell out BARNDLES with BARNDLES. But I don't think that's going to be super practical in this situation. I'm just going to test out as many of the instructions as I can in like a really long and convoluted situation here. Somebody said Fibonacci. Fibonacci would be a good idea, except I don't have jumps, and I'm not sure how I would do that without jumps. So let's go ahead and get started. I'm just gonna basically, I think what I'm gonna do is just go through my list of instructions here and basically just execute one of each of these. We'll start with the arithmetic, which are move, add, subtract, multiply, and divide. So this is really simple in how this works. So I'm gonna start off with a move instruction. So I'm gonna say move R1 and then a value of 100, okay? And basically what this means is that I'm going to, I wonder if I can make this bigger for you guys. This seems a little bit small. Editor, font size, let's go 20. There we go, okay. So hopefully this is a little bit more legible for you guys. So move R1 100 is going to, or actually somebody says, what is the assembler for? The assembler is for a computer that I'm building in Blender. It's called BARNDLES. So yeah, that's the gist. Somebody asked, do all of your instructions in the table work? As far as I know, all of them except for branch or jump instructions work. I haven't confidently tested them though. That's why I'm writing my assembler so that I can better test these instructions. So anyway, back to whatever this instruction means. This move R1 100. Basically, what I've said here is that I want to move, which is this MOV, a value of 100 into register 1. And for those of you who aren't familiar, a register is basically a hardware component that stores a number. It can be any number. It's basically like, you can view it kind of like a very primitive variable. And in this case, my BARNDLES system has 16 registers. So we have R0 through R15. Of these though, it's really important to note that only R0 through R11 are general purpose registers, things that we can use to write our program. R12 through 15 are all special purpose and serve some sort of system use that we aren't going to get into, and actually we might be getting into a little bit. But anyway, first things first, let's move a value of 100 into R1. Then let's move a value of, let's say 50 into R2. So there we go. We have now stored with these two lines of code a value of 100 in R1 and a value of 50 in R2. Now let's do some math with these. Let's add these numbers together. So I'm going to say add, which is another instruction from my table here. And I'm going to add the value of R1 and R2, and I'm going to store it in R0. So the way that these work, that instructions work, so move is a very basic operand. It's basically saying R1 equals 100 or R2 equals 50, right? It's always the destination register that comes first here. After that, we have either some sort of operand register, meaning where the numbers are being pulled from, or some sort of immediate, which is what 150 are. Immediate values are basically constants, like things like 100, 50, stuff like that. So if I wanted to add R1 and R2 and store it in R0, if we write this out as, regular, what we would look at in the real world, we'd say that R0 equals R1 plus R2, right? So then if we want to write this in assembly, we'd say add R0, R1, R2, which is basically saying R0 is equal to R1 plus R2. Or if we wanted to subtract the two, we could say sub R0, R1, R2, which is the equivalent of saying, again, R0 equals R1 minus R2, right? So these are the most simple lines of code that we can basically work with here, are these very arithmetic instructions. Can you explain what you mean building a computer inside of Blender? Do you mean a physical Blender or the 3D software? I'm talking about the 3D software. So I built a shader in Blender that, if you're not familiar with shaders, it basically manipulates how the surface of a 3D model reacts to light. And I use that shader, oh hello, welcome back Barndles.
I am back.
I use that shader to basically create an actual functioning computer, and that's what I'm writing this assembler for. Let's see, what else did people say here? Have you been able to implement pipelining? Colton, no, I'm not implementing pipelining. I would cry. Pipelining, for those of you who aren't familiar, rapidly speeds up the way that instructions flow through a processor, because it runs multiple instructions through the processor at a time. That is crazy. I'm not doing it. I'm not touching that with a 10-foot pole, especially in Blender. It's horrible. It's horrible. Is this the NAND to Tetris architecture? No, this is a fully customized architecture that I built for Barndles. So this is the Barndles architecture. So anyway, yeah, it is named after Barndles. So anyway, basically what we've done here is we've moved a value of 1 to register 1, or 100 to register 1, a value of 2 to register 2, and then we've added the values of R1 and R2 and stored that in register 0. So now, with that extremely simple assembly code, let's go ahead and try and write an assembler for it. So this assembler, again, as I mentioned, is going to turn this assembly into machine code. So first thing I'm going to do is file equals open main.s, oops, probably turn this into a string, main.s, and then we want to read from it. And I just put a semicolon at the end of it because I'm so used to programming in C and Java and stuff. Can we see your ALU for a second? Yeah, let me open up Blender here. This is going to be an extremely unproductive hour. I'm probably not going to be done with it. So the ALU is in the execute phase here, and we have our ALU, and here's what it looks like. So basically we have a 0 operation, a pass A, a pass B, an A plus B, A minus B, A times B, A divided by B, A bitwise and, A bitwise or, A bitwise exclusive or, A logical and B, A logical or B, A logical exclusive or B, logical shift left, logical shift, wait, what? This should be, logical shift left, arithmetic shift right, and arithmetic shift, logical shift right and arithmetic shift right. Jeez, I cannot read. And then we have some other detection here. So this is basically the top level view of the ALU. Once I'm done with this project, I will be making this all open for people to look at though. Anyway,
I got none of that.
It's all right. If anybody is familiar with computers, you'll know what that is and what that all means. Computer architecture, at least.
I know a lot of what the functions were, like exclusive or and stuff like that, but
Do you know what a ALU does, Barndles?
No, not at all. Okay, not even a little.
So just
I don't even know what it stands for.
ALU stands for Arithmetic and Logic Unit, and basically the ALU is the part of your processor that actually does the computation. So it contains logic that can actually add two numbers together, or it can actually subtract two binary numbers from each other. And basically what we do with the ALU is we pass in two numbers, A and B, and then we have a third field that allows us to select which operation we want to be running. Whether we want to be adding numbers, subtracting them, dividing them, logical shifting them, all sorts of stuff.
Okay, so what is a logical shift?
A logical shift? Oh man. Are you watching the stream right now?
Yeah, but it's got a little bit of a delay.
It's got a little bit of a delay, but I think you'll have to put up with it. A logical shift is basically if we have a number, a binary number, say 10100110, right? I know this is going to take a second to appear on the screen. If we wanted to logically shift this left 2, right? Basically what that means is we're taking every single binary number and moving it left 2 spaces. It's really simple. So the end result would be 1001100, where the entire number just gets moved right 2 spaces. So now we got 2 blank zeros here. I don't know if you got that.
It just showed up.
Yeah.
Okay, yeah, that makes sense.
And then logical shift right would be moving it in the other direction. An arithmetic shift just keeps the signing of numbers, but I don't want to get into that because that's going to be way too complicated to explain.
So what do you use that for?
It's really useful if you if you shift a number left by 1 space, you're actually multiplying it by 2. So it's really useful for quick shifts. And then if we get into embedded stuff as well, which embedded systems is basically putting little computers in things. So like putting a computer in Tickle Me Elmo or putting a computer in a car, right?
Nice.
At a very low level, logical shifts can be extremely useful for setting certain fields and stuff like that. I can't really explain it all in such a short period of time, but it's got a lot of applications. Just trust me when I say that.
Fair.
Okay, so in this actual code here, I'm gonna say for line in file.readlines, which I'm pretty sure works. I haven't done anything like this in a long minute or hot minute, so we're gonna have to see. So line is going to be a string, right? Yeah, line is gonna be a string. So basically, can we like tokenize this? Line dot. How can you tokenize? Okay, hang on. I gotta search up some documentation. Python tokenize string. Oh, python.split. Okay. Returns a list of strings after breaking the string by the specified separator. Okay. And in this case, can we just leave that blank and it'll assume that it's white space? It looks like we can. Okay. So, do we have switch cases? No, we don't have switches in Python, do we? Somebody asked, what language is this? This is in Python right now. And then this music is very relaxing. It is. I don't know what it is called. I just searched up copyright-free jazz. So, anyway. So let's see here. Basically, in order to figure out what operation we need to be executing, I first need to look at the first token, right? By the way, a token is basically splitting things up by spaces. So if we tokenize this top line here, it's going to split up into move, R1, and 100, right? So let's first get the first token, I guess. So we'll say first. How do people name things in Python? I forgot what the Pep8 naming scheme is. So,
I used Python like twice and it was on Code Academy, so I don't think I have any good input here.
Okay, we'll just call it first talk. Okay. I keep putting semicolons at the end of my lines. Okay. Second talk is going to be tokens 1 and wait. Oh, here, you know what? This is what we can do. We can say... no. Man, I'm starting to think I should do this in C, because I'm more familiar with C than I am in Python now. At the same time, I don't know if I want to do that. Okay. So, we'll say... Gosh. I don't want to split this up yet. So, we have a list of tokens. So I guess we can say, we'll just do an if statement now. So if tokens 0 equals move, all right, we're just gonna print out to the console move, and then else if tokens 0 equals add, then we'll print add. And Oh wait, this is not else if, this is elif. Elif tokens 0 equals sub, then we're going to print subtract. And finally, elif tokens, oh wait, this isn't finally. I've never actually tried coding on live stream before, but it's a lot more stressful.
Yeah, it sounds like it. There's a reason I didn't stream any of my game jam stuff.
Fair enough. Somebody says use a dictionary as a switch. That might be a good idea. I don't remember how to use a dictionary as a switch though, if I'm trying to figure out what exactly something is. Anyway, that's not really the important part here. The important part is that we should be able to now run this and it'll open up main.s and it should print out move, add, right? Because we're going for each line, we're getting the tokens. I'm gonna add some comments here. Tokenize the line. Okay, so for each line in the file, and then add file. Okay. Switch on first token. Or the operator, as it's known if we look at it from an assembly perspective. So how do I run this in here? Okay, run assembler. There we go. So look at that. We just went through our file here, and we can see that our first line is a move instruction, our second line's a move instruction, and our third line is an add instruction. So maybe what I should do here is, dictionaries are great in Python. Let me look up how to use a dictionary as a switch. Dictionary as switch Python. How does this work? Python doesn't provide a switch case instrument. Switch case using a dictionary. Def Monday, return Monday. Okay, and then you create oh, I see how this works. Okay. That's not a bad idea, whoever recommended that. So let's see here. Let's just say def move. Return, for now we'll just return 0. Def add, return 0. Def sub, return 0, and then def mul, return 0, and then def div, return 0, and then we can say that our instructions, or we'll call it instruction dict, is going to be, we'll say move is our key, and then move is going to be our instruction, our actual code that's going to execute. Add is going to be add. Sub is going to be sub. Mul is going to be mul, and div is going to be div. Man, it's a lot harder creating, trying to talk about this stuff in context of live streams than it is Blender stuff. Okay, so basically what I want to do now here is say, what is this? So if I say instruction dict.get and then token 0, what that's going to do is it's going to basically try and fetch the 0th item of the token. So let me try this again. So print move. I probably should have just copied and pasted this instead of deleting things. Okay. Add, subtract. Wow, I just typed that with one hand. That was kind of impressive. You can type subtract with one hand, can't you? Can you? Sub. Oh, you have to reach. You can almost spell it with one hand.
I mean, you can. It's just not good.
And that didn't work at all. That's okay. Let's try that again. No. Alright, so why isn't this working? That's a puzzle. Oh, Tabby, thank you for the super chat. I appreciate. He says he appreciates my confidence to code on stream. I appreciate you appreciating me appreciating my confidence, because this is taking a lot. Let's see here. So how in the world is this supposed to work? What if I return something? Hello. I have caps lock on. Man. So that doesn't work the way I thought it did at all. Oh, unless the tokens aren't matching up? No. They should be. Okay, so those are the right tokens. Yeah, maybe I do just have to do an if statement, or really, maybe I should just do this in Java. Okay, well, you know what? I'm just gonna go back to using my switch statements. I might redo this in Java later, but for the stream, I'm gonna stick in Python and try and figure out how to do this. So... Oh wait, you know what? I can do this, so I don't have a bunch of code here. This is a much better, okay, this is a better approach right here. So basically what I'm doing is the same thing that that dictionary was supposed to do, except it will defer to an actual function instead. Which is going to help me keep my main method here, or my main code that's executing the actual script, a little bit cleaner. Okay, elif operator equals div, then div, else print unknown. Okay, so then we can move that print move back up here. And now this should work, unless I'm on crack, which is a totally viable option here. What is this yelling at me for? Expected 2 blank lines.
Very likely that Grant is on crack.
There is a 48% chance.
That is a lot higher than I would hope.
Okay, we'll remove some things here so this stops yelling at me for using PEP8 crap. Please work. And there we go, ladies and gentlemen. That might be hard to see, but we did just get move, add, which lines up here. Let's just add some extra lines of code. Add R1, R2, R0. Sub R0, R1, R2. Div R0, R1, R2. And then mul R1, R1, R1. So basically just multiplying R1 by itself. This is if this line is the equivalent of squaring R1. And so we should get move, add, subtract, divide, multiply. Bingo. And then what if we do something that doesn't exist yet? Or R1, R2. Unknown. Okay, cool. So we'll leave that or off for now. And you know what we're gonna do here is we're actually gonna create a separate Python file here called instructions. And instructions is going to hold all of our variables or all of our functions for handling the it'll handle all of our functions for actually calling things here. So actually, let me rename this. So import instructions as inster. So inster.move. Nope. Inster.move. There we go. Okay, cool. Inster.add. I don't know why that subtracted itself. and self-tiny, instr.sub, instr.multiply, instruction divide. Perfect. Okay. This is looking a lot better now. So basically what we've done here is switch on operator. What we've done here is we've gone through each line in our file. We tokenize each line. We get the first token from that line, which happens to be the operator, and then we switch on that operator. Oh, my cat just jumped down from my bed. Want to go outside, Squidward? His name's not actually Squidward. Well, yeah, his name's Edward, but we have a bunch of weird names for him, including Squidward, Scoobert, etc. And basically here we just switch around that operator to determine which instruction handling method we need to call. Whether that's move, add, subtract, multiply, divide, because each of these instructions is going to have something completely different that we have to work with. So, let's look at our instructions here. Let me document these a little bit better here. This is going to be move instruction, I guess actually, no, we don't need to do too much here. Okay, so now that we have the operators figured out for this subset of our instruction set, we now have to learn how to read the operands. And the operands are this second half here, where we have R0, R1, R2, which is saying add R1 and R2 and store it in R0, or move the value of 100 to R1. We have to figure out how to actually process these and how to parse them and figure out what to do with them. So I'm thinking I might just need a fully separate method that can handle this, because or a fully separate function, because each of these lines or each of these instructions can have a different set of parameters. So you can see like the do nothing command actually has no parameters. It's literally you just write Don. The move command.
It's just my friend Don.
It's just my friend Don. The move command has RD and RM, but the add command has RD, RM, RN. It takes 3 registers. Or even if we get down into the memory fields here, we can have really weird things that we have to figure out how to work with. So I have to find a way to balance these out. Let's see here. So, all these are going to return. And somehow I need to parse these. So maybe I should make like a... Actually, maybe I should rename this. I don't like the naming convention I have here. ASM, instr, and then... Sorry, I'm picky about naming conventions. ASM, assembler. Okay, and then I'm going to create a new one here called ASM utils, which is going to house some functions for, well, in this case, we're going to name this one parse, what are we going to say here? Parse, what are the things to the operands? That's what it is, operands. And then we're going to pass in the tokens. Okay. And that also makes me realize that I should probably be passing in the tokens here. So instruction instead would be a better way to name this. So instruction, and then we're gonna go ahead and pass in instruction to all of these so that when we actually run our code here, we have access to them. Grant, how late are you planning on streaming? I don't know, probably to like 9:30, maybe 10.
Until the end of time.
Until the end of time. I'm not gonna stop. I'm just gonna keep going.
Physically, he can't. He's not allowed to anymore.
I just splashed water on my face. Okay, so anyway, basically what we're doing now is we decide which code that we need to run based on the first token of the instruction, the operator of the instruction. Then what we're going to do is we're going to parse the instructions in these. So I should probably do import ASM utils, and then we're going to say parse maybe I should rename this as ASM utils, no, ASMU, sure, we'll call this ASMU, ASMU.parse operand, oh, no, parse operands, and then the tokens are going to be the instruction, like that. I'm going to actually rename these local variables or these parameters a little bit here because I think they're kind of poorly named. See, this is the hard thing about doing this live, is that there's so many things that I like to change, you know, where I'm working on something and I can just change it whenever I want. But then when people are watching me, I have to at least like ignore some of them so I can.
Or just make them watch. They're a captive audience.
Just make them watch, yeah. They're basically, yeah, it's everybody tied up. Okay.
Yeah.
So parse operands is going to do what? Parse operands is going to take up, is this like assembly, the low-level language? Right now this is in Python. I am going to be using Python to actually parse the assembly. This is the assembly right here. And I'm basically assembling that. So we're gonna parse those operands, and by parsing the operands, we need to figure out a few things. We need to figure out whether we're running an immediate instruction. We need to figure out whether we are running, what else do we need to figure out? Man, this is a lot harder than I thought it was. I didn't think this out as far in advance as I probably should have. So we have to figure out whether it's an instruction or a register instruction, or an immediate or a register instruction. We need to figure out how many immediates there are. Also, the music could be a little quieter on stream. All right, I'm gonna tone it down just a hair then, because I'm not talking as loud as I was before. We'll kill 3 decibels worth of sound. Hopefully that sounds a little bit better. Okay. Maybe instead of parse operands, we should do something else first, which would be def. So def get operand type. Okay, and what operand type is going to do is it's going to tell us if we have. So it tells us if we have an immediate instruction or a register instruction, or what did I refer to it as in the actual documentation? Not immediate. Wow, that's as an immediate instruction or a non-immediate instruction. So an immediate or non-immediate instruction. So we're gonna pass in our tokens, and for token and tokens, actually we'll say if tokens 2 or tokens, actually tokens 1 or tokens 2. Tokens 2, how do you do, wait, tokens 1. So that will give us the first token. Is dot contains a thing? I hope dot contains is a thing.
If I say yes, will you believe me?
No, frankly.
Good. That's a good call.
Okay, so basically what I've done here is I wrote a function to tell us if we have an immediate instruction. So I say def is immediate, so that's our function definition. And if the, oh wait, no, this should be 0,
you just
1,
said death is immediate,
3.
and I was terrified.
Death is immediate. It's a threat. So basically what this is seeing is it's seeing, oh wait, but we should probably get our number of tokens first. Shoot. Or let's do a short circuit here. Tokens dot size, is that a function in Python? Gosh, I really need to catch up on my Python. Let's see here. Let's see, list.size Python. Oh, len. Len is what it is. Len tokens is what I want. I forgot about len. Okay, len tokens equals 3. So basically what we've done here, can I fit this all in one line? Oh, we're just a few things off. Ugh. I'm gonna have to split my line. Okay, whatever. So basically what we're looking at here is we're saying if the second token contains a pound sign, which means it's using an immediate, or if the third token contains a pound sign, then we are working with an immediate instruction. Or maybe we should say the last one. Yeah, it should be the last one because the immediate is always the last one. So if tokens, let's see here, this is a bad approach. So if tokens, len tokens -1, right? Because if we have 5 elements in our array or our list, and we get the length of that list, it's going to be 5, which is going to be 0 through 4. So 5 minus 1 is 4, which should be the last one. So this basically says if the last token in our instruction contains a pound sign, that means that we're working with an immediate instruction. So there we go. Okay, what else do we have going on here? Okay, but why are you trying to do this in assembly? So basically what I'm doing is I'm writing an assembler for a computer that I built in Blender. And I need an assembler to be able to run code on it because we need very low level code to run on this custom architecture that I built. What else? I actually quite like coding in assembly. So do I. It's kind of nice. I watched the Beginner C# Code Academy's video once, so yeah, I'm almost a master programmer. Clearly.
I feel like my job is just going to end up being telling you what the chat's saying.
Yeah, I mean, if you want to do that, you can. Or you can just chill around.
I mean, I'm just playing Factorio right now, so it's not going to be much different, yeah.
Factorio. Alright, you got me here now, Mr. Discord Ignore. Oh, Jack, were you sending something in Discord? I haven't been looking at Discord. Grant, why'd you do this to us? Is YouTube better than us? Yes, it is. Just kidding. Isn't Cheat Engine in hexadecimal? Cheat Engine allows you to adjust hexadecimal values, yes. Doesn't do much other than that though. Okay, so the first things first, we need to check if we're working with an immediate instruction. So if ASMU.isImmediate, and we pass in our tokens, then we do something, else do something. Okay, so we're gonna write this just for the move command first to make sure that it's working properly here. So, let's see here. If ASMU is immediate tokens, do something else, do something else. Okay, so we check to see if it's an immediate, and if it is an immediate, then we're going to do def parse immediate? No. How do we want to do this? We should start from the back and move forward. So I'm going to say tokens. So basically what this is going to do, this function is going to actually help us parses an immediate instruction. Okay? And returns the operands. No, we won't do that yet. We're gonna figure out how to parse the instruction first. So we're gonna do this back to front because the backmost one is going to be the actual instruction with the immediate in it. So immediate equals token len tokens -1. Okay, and then tokens len token -1. RD is going to be tokens len tokens +1, right? No. This should be, because we should definitely always have an RD value. So this should be the first element, okay? And then RN, we're not always gonna have an RN. So, let's see here. That's gonna be the last one. So then if len tokens is less than 1, 2, 3, 4, or actually is greater than or equal to 4. Oh wait, we need 2 different approaches. Okay, so if it's less than or equal to 4, then we take this approach. If len tokens is less than or equal to 4, or sorry, less than 4, we need to take a different approach. Actually, these should be identical. So if there are more than, actually there should be, if it is 4, because we'll never have more than 4 instructions. Are there 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3. Some of these are just RD. Okay. So it always has an RD, right? Except for do nothing. That's something I have to keep an eye out for, is do nothing. So that's something I have to keep an eye out for. But if it does equal 4, then we're going to have an RN as well, which is going to be tokens 2. I guess we should have another thing here checking to see. Oh wait, no, because with the do nothing instruction, actually I'm going to implement the do nothing instruction because that's kind of an important instruction too. So if operator equals Don.
Don's a cool dude.
Don is a cool dude. Don.
What a guy.
Okay, Olif. Okay, so this makes a little bit more sense. Now we need a Don, so def Don tokens. Although actually Don doesn't need any parameters. Return. Well, Don doesn't get any tokens. Just kidding. Don's the poor kid at Chuck E. Cheese that gets no tokens.
Don's
oh boy.
a loser.
Don't call Don a loser.
Why not? What are you gonna do about it, Grant?
I'll drive to Oklahoma and break your knees. That's what I'll do.
Oh no.
Oh no.
I need those.
I need those. Let's see.
Those
Jack
are
says your walkers. Jack said you have different types of instructions, right? Wouldn't that be a perfect case for polymorphy or polymorphism? I'm guessing that's what that is similar to. Have an instruction master class and then subclasses. Yeah, sure, that would work. Except that's not going to be really important for something that's just parsing information. If I was doing more with it, I might implement some sort of superclass, subclass, and inheritance system with object-oriented programming. But in this case, I'm basically just making a script. So, what else here?
You just said words, and I understood what the words were, but they just like, it was like you were speaking a different language. It was like runes.
Vamos a hablar en español ahora?
See, but I kind of get that.
¿Entiendes esto? Muy bien. Okay. So, where was I going with this? Oh, I guess I don't even need to do this. So if it is, then this should be the third one, and if it's less than 4, then this should be the second one, because otherwise it's not going to be detected as an immediate. Wait, but what if it is an immediate? Oh no, we have instructions where the first thing is an immediate. Okay, so we need to be more specific here. So if there are 3 tokens, then we do this, and if len tokens equals 2, then...
Zohab didn't know you could speak Spanish.
Zohab didn't know I could speak Spanish? Sí, hablo español.
That's wild.
I haven't spoken it for a while because I have been out of school for... Or, well, not out of like high school where I actually did Spanish stuff.
Fair.
For a hot minute. I keep adding spaces where I don't need spaces. Okay. Oh my gosh, you don't have to cast types in Python.
Crazy.
That's mind-blowing, man. Holy cow.
Apparently I disliked this stream. Wait, what?
Barndles, get off. You're not allowed.
I haven't even like interacted with the UI. Apparently my computer hates it.
Okay, so after we've determined whether or not it's immediate, We want to either parse the immediate. Okay, so what about parsing non-immediate? So parses the values of, or the operands of a non-immediate instruction. Okay, parses the operands of an immediate instruction. 3 operand immediate instruction. And I haven't done anything with these yet. I'm just trying to get my plan set out here. 2 operand immediate instruction and 1 operand immediate instruction. Okay, so we've got those parsed out. Def parse non-immediate tokens. So then we'll do the same thing here. We'll have 3 operand immediate instruction. And we'll say if len tokens, actually we can just copy and paste this for the most part. So we should have, oh wait, 2 operand immediate instruction. Okay, so a 3 operand immediate instruction or non-immediate instruction. Copying and pasting things. Okay, 2 operand non-immediate instruction, 1 operand non-immediate. Okay, so in this one it should be RD, RM, and RN in that order. So this is kind of off. Wait, is it like that? RD, RM, RN. Oh, so this one, these should be RM, not RN. Oops. Okay. RD, RM, RN. RD, and then RM is going to be, wait, no, we have, okay, so here we only have RM, which is going to be tokens 2. And again, I added a weird space for no reason. And this is RD then, I guess. I don't think I have any 1 operand instructions. Let me look at this again. So here we have, oh, you know what? With immediate instructions, I need to be more specific here. So with immediate instructions, we have RD as the first operand and as the destination. So I should be more specific here. So RM, actually, you know what? Maybe I should just pull this up like this. This might be a better idea. Okay, so for my non-immediate instructions, RD and immediate 12. So then 0, 1, RM equals, okay, we just say RM equals RD, and then this is going to be tokens 2, because we're never going to have something with 3 arguments. So 2 operand, immediate, 1 operand. Okay. Matthew Gilbert asks, what's the deepest node group I've got? I'm pretty sure that's my ALU, which I showed off earlier. So if I come in here, we go to execute, ALU, and then maybe one of these, maybe the shifts. Yeah, that's about 6 deep. I think I've got a deeper one somewhere else. Maybe in my memory or something, or the mux. Oh, I got, my multiplexer get pretty deep pretty quick. Or converting, oh, here we go, converting uint24 to binary. That's where it's at. That's quite deep.
Oh boy.
That's always fun.
I made a procedural iron shader once. That was pretty crazy.
Yeah, that is pretty crazy. RM equals RD. Okay. RDRM, RDRM. Ah! Reconnection successful! We're live again! Oh my goodness. Well, that was unfortunate. That was really unfortunate.
Boy, howdy.
Hello, Barndles. Did we just lose literally everybody that was watching? It said I'm down to 5. Oh, now we're up to 9.
Yeah, pretty much everyone.
Bye, everybody. Hopefully some of you come back.
Nah.
Anyway, my friend just said, did a tree fall on the power line again? I don't know. I don't think so. I think my Wi-Fi just went out there. Gosh. We love internet, especially Corona internet, where it flickers on and off. Alright, where was I? I forgot where I was at completely. Oh yeah, I decided that I'm going to turn these into, this doesn't have an RM. I'm going to turn these into,
I thought your internet died again.
Okay, no, I'm going to turn these back into a dictionary, which is going to be returned, which is going to make the actual parsing of these values easier. So I'm going to say return, actually I'll say opdict is going to be rd, which is going to be, or I guess rd, which is going to be rd. We're going to have rm, which is going to be rm, rm, and then imm, which is going to be imm. What is this yelling at me for? RD might be referenced before assignment. Oh, rats. Should probably do this. So opdict equals this, and then opdict equals this. Okay, and then we can return, because it's just going to be the immediate, return opdict. Okay. So, what else might I do here? I don't know. This seems pretty solid for what I've got going right now. I'm actually kind of digging this big font stuff. It's nice to look at. It's easy on the eyes. Okay, RD is going to be RD. RM is going to be RM. And then RN is going to be RN. You know what happens in Python if you add a variable that isn't defined? Do you get an exception? What happens if you access an undefined variable in Python? That isn't, okay, so it does look like you get an exception for that. All right, that's good to know. So let's define this. This one's just going to be RD and RM, and then this one's just going to be RD. Okay, so then return opdict. Okay, and then more specifically, I need to do some, oh, you know what? It might have been referenced before assignment. Because what if the tokens aren't, okay, in that case, we'll just return a null opdict, or an empty dictionary. Okay. Okay, and I can't shrink that down for some reason, which is mildly irritating, but that's all right. Okay, so now we have 2 and 1 operand, which is right because we have 2 operands and 1 operand, and then we have just 4 3 2 1 3 2 1. Okay, cool. Barndles, are you still there?
Yeah, I'm on push to talk because my keyboard's loud.
Okay, that's fine. I was just curious because I didn't know where you went and you were being quiet.
Duh.
Okay, so now we have. Oh wait, and then in addition to this, what I need to do is if it is an immediate, I need to get rid of the pound sign before it. So IMM dot. So it's the second token with, let's say, 1 2, right? That's how you say. Remove the first character of a string Python. So if you want to remove the last character, wait. I hate how much documentation there is. Okay, AB returns the substring of length B minus A, starting at the character A and lasting until B. Okay, so that should be right. So that gets rid of the pound sign at the end of the second operand, or the immediate operand. And then we shouldn't have to do anything like this here because this is going to be, oh, there is something we should do here though. This should be, so this is going to be reading in values like this. So this is going to be R0, R1, R2, R3. So maybe I need a separate function for this. So let's say def remove or parse no, I already have parse immediate. Parse IMM operand, parse immediate operand. There, here we go. We'll do parse immediate operand. And what this is just gonna do is it's gonna remove the first character of that operand. Oh wait, remove. I meant to say return. So that's just gonna, so this is basically going to remove the pound at the beginning of an immediate operand. All right, and then we're gonna say def parse parse non-immediate operand, and then the operand. And basically what we're gonna do here is just going to do the same thing actually. Operand, we're just gonna remove the first character. So maybe I should just say parse operand, because these are gonna be the same thing. So this is going to remove the pound at the beginning of an pound, or R at the beginning of an operand. So this basically will remove any characters and turn these into, or any non-ASCII characters and turn these into numbers. So I should say parse operand tokens 1, and then we do the same thing here. And basically what this will do is it will, when we return our dictionary, it will instead say RD is going to be 5, RM is going to be 6, IMM is going to be 100 or whatever, as opposed to saying pound 100, pound 50, all that stuff. In Jebs, I don't know how to pronounce that verbally, but asks what's an assembler. Basically an assembler takes high level code, well an assembler takes a low level code called assembly language, and it converts it into machine code, which can actually be read by a computer. There's a more detailed description in the actual description of the live stream right now if you just want to look at that. That will give you a better idea of what it is and what I'm making it for. Okay, so that seems correct. So now what about these? Okay. Perfect. I don't like how Python doesn't have data types other than objects. It really kind of frustrates me. It's been bothering me this entire stream. I'm really thinking I should have done this in Java, because then I could have at least had specified object types or data types. Okay. So if it's an immediate, we should say parse, or maybe we should say operands equals parse, or ASMU dot parse immediate, and then pass in the tokens. Otherwise, operands equals ASMU dot parse non-immediate tokens. Okay. And then let's print the operands. Like that. And I guess we'll just do that for the move instructions. So for the rest of these, we'll just ignore them. Yeah, let's just see how this, okay, so immediately we're met with some issues. So is an immediate, contains, string object has no attribute contains. Check if character is in string Python. Oh, you know what? I probably should cast these to ints too. So there should be int. Like that. I forgot that there is some sort of casting. Okay, the find method checks if a string contains a substring. If it does, the method returns Or, oh, I could have used in. That's a better approach. Or even past that, check in IfImmediate dot get, is that one? Dot count, get character from string Python. Is it just dot get? Oh, I can just do 0 because you can take up each character, okay. So in parse operand, that invalid literal. Oh, okay, so wait, this is passing it R. So why is this passing it R? Did I not do this rightly? Or rightly? Rightly. Let's do print operand. Print operand. Oh, I know what it is. It's supposed to be the first character on. That's what I did wrong. I did until the first character. Okay. So now what? Move T. Can only concatenate string. Oh, I need to cast operands to a string. Okay. Ah! Okay. Let me remove some of my other assembly here. Okay, so we don't get the proper values out of here. Oh, I did. Okay, so this should be else elif. That's what it is. So we were overwriting our original optic because I didn't do elif there. What about in here? Is this if, elif, and then elif? There we go. Okay. That's correct then. So basically, what we've just done is we have split up. Our first instruction is going to move from register 1. Actually, it's going to actually, no, this is wrong because this is a move instruction. A move instruction only has 2 parameters. This shouldn't have an RM. But do other things have an RM? No, because this is immediate. So this is an immediate 2-value instruction. Parse immediate. Where is move? So move is going to be RD and IMM12. Ah, see, that's an issue. Okay, so basically when we're executing a move command, it should only have actually 2 parameters, right? We have immediate 12, which is going to be the actual immediate that's being passed in this case 100. And we have RD, which is the register where it's being placed. Right? That's how a move command works. We're basically saying move the value of 100 to RD, or the destination register. The issue is I wrote this assembler so far with the consideration of these other instructions. What's actually happening with these instructions is we're adding multiple numbers together here. So our add instruction is actually saying, actually you can see its equivalence here. What we're actually doing is, although we only have 2 operands here, we're assuming that the RD operand serves multiple purposes. We're assuming that it works both as the destination and as the first operand register, which kind of throws things off, right? Because that means that we have 2 different functions for RD, but in the move instruction, we only have 1. And the move instruction is the only instruction in the BARNDLES architecture, in the BARNDLES instruction set, that only has 1 use for RD.
I don't think that's ever not going to throw me off.
You don't think that's ever not going to throw you off?
Yeah.
Maybe. I don't know. Okay, so if we go ahead and maybe take into consideration, maybe we'll leave the actual processing of the RM component to something else. So instead, we can use RM later if we have some sort of other operation. But now we should say, see, move, and we've extracted a value of 1 for the destination register and 100 for an immediate. So let's try some more move instructions here. Move R2 200, and then move R2 R1. Let's try that. Okay, so here's another issue. For some reason, it's labeled this as an immediate, even though it's not an immediate. So this one works, these two work correctly. This one, it's saying that our destination register is 2. This should be RM, which is our first operand here. So what's going on here that's causing our thing to be interpreted as an immediate? Did I forget to rename one of these? No. Okay, so maybe our is immediate isn't working correctly. Ah, that's why. I'm returning the first character, which is going to be true always. So if it's equal to $, that's what we want. So it's saying if it has a first character is what that was saying there. Now we're saying if the first character is something specifically, and there we go. So we're basically working with our things here. We're working with our move instructions. Let me try some more. Move R2, R3. So we're moving register 3 to register 2. Perfect. That looks like it's working properly. All right, catching up with some of the chat.
The stream is definitely frozen, but I still hear you through Discord, which didn't happen last time.
That's so weird. I'm gonna stop my Minecraft server for a little bit.
Sure.
Because I think that might be contributing to this issue a little bit.
Might want to warn people that you're
nobody's
canceling
on
Minecraft.
If you could send a message in the Minecraft channel, that would be nice, Barndles. But anyway, hopefully that with the server stopped, we won't have any more stream issues. I feel like that's contributing to the problem here. So what else here? But yeah, I basically took a break from Barndles for a few months, came back to it and implemented a whole bunch of other stuff. So yeah. Who else? What will the computer be able to do? It's going to be completely functional. If I wanted to, I could write a compiler to compile Blender and then assemble that and run that on Barndles. Now, unfortunately, Barndles isn't going to be nearly capable enough. It would literally take a year to just pull up the default cube, but it would be...
That's a start.
It would be possible to do so, which is really cool. So yeah, that's what this computer is going to be able to do. What have you finished so far on the CPU? So the CPU so far is actually pretty much done. I've done most of the microarchitecture components of it. And right now I'm writing the assembler so I can write code for this that actually runs on this and actually test it to make sure that it's working in the ways that it should be. So there we go. So let's do this for our add instructions now too. So I guess this is going to be pretty similar here.
You're going to be pretty similar here.
Your face is going to be pretty similar here.
Okay, well,
after
that's just mean.
Smash it with a pan.
That's cool.
That's cool, I guess. Oh wait, I didn't want to do that. Okay, and then this is going to be divide. Okay. Let's just run this again. All right, and let's add some extra instructions in here. So we know that we can do 2 operand immediates. So let's say add R1, R2, R3. Actually, you know what? In most assembly languages, there are commas in here. Maybe I should do commas. That's really kind of throwing me off. Yeah, I'm gonna do commas. So in parse operand, we're gonna do no prefix, I guess, and that's going to be this, and then we're gonna say if operand, oh wait, oh, you know what? We're gonna say if operand and then len operand -1 is going to be a comma. Okay. If the last character is going to be a comma, then we want to do this to len operand -1. Actually, we want to do -2 here. Okay, so basically this is saying if the last character in the operand is a comma, then we can get rid of said comma thing. Am I the only one who has the video still frozen? I think you are, because I see my own video. Maybe refresh the page, Jack. So this should get rid of the comma at the end if it has a comma. If it doesn't have a comma, then it should just be going on, but that did not work. Okay, in parse operation, return int, unsupported types, string int. Wait, unsupported operand types, what do you mean? Operand? What does this mean? Unsupported operand types type error. Is this telling me that I can't? Did I save this? I don't know. Ah, why? Oh, I'm dumb. God, I'm dumb. Okay. Okay, now we get a different error.
Building a computer.
We get shut up. We got a different error. That's always good. Okay. Invalid literal for int with base 10. So maybe this should be -1. Bingo! Bingo was his name-o. Nice. I was so confused for a little bit there. So just for you guys who are curious, what I had wrong there is I had len operand -2 right here. So it was trying to subtract 2 from operand, but operand was a string. So I meant to put it out here. That's what went wrong there. So yeah. Okay. So let's try. So this read RD, RM, RN. Sweet. Okay. So let's do sub R1, R2. Oh wait, R1, 100. It's gonna work. It's working. It's working. I'm gonna get rid of the full name here though, because I think that's going to kind of make my things not look good. Okay, so this means we have, let me get an example of each of these in here, so hang on. So this is a 2 operand immediate. What if I just had move 100? This is just an example. Okay. This isn't actually going to be actual functional code here, but it's important to test to make sure it works, because if this is like replaced with a branch or something like that, that's fairly important. So we've made sure, I should probably check the number of, so if len tokens is less than 2, raise, how do you do exceptions in here? Python exception, raising exception, raise meme memory error. Oh, I was just gonna say meme. Raise, can I create like oh, you know what? I probably have to do something specific. Is there anything here that might fit my... Yeah, there's not gonna be anything in here that really fits my... We'll do syntax error, I guess, and then can I write a message with it? Raise error Python with message. Syntax error. Oh, I just went back to the same page I was on. So that's a try except. How do you raise them? Raise. There's just something that says raise. Name error. Okay, there we go. So it's syntax error, and then we'll say move has too few arguments or operands. Move instruction has too few operands. So then, wait, what? Oh, this is supposed to be len tokens. Okay. Oh. Oh, wait. Oh, shoot. I'm so dumb. Okay. And when you raise a syntax error, does that not exit out of the function? Oh, wait, less than or equal to 2. There we go, okay. So we'll say less than 3. So catch move instruction with too few operands. Oh, maybe I should create a function for this. So, no, not right now, actually. Catch move instruction with too many operands. And then we'll do the same thing here. It's greater than 4, right? Because it should have exactly 3, no matter what, right? Let's see. If it has 1, 2, 3, 1, 2, 3. Okay. So then if we do R2, R1, R2 again, then this should raise an exception as well. No, that's not going to raise an exception. Great. Oh, greater than 3. So it has to have 3 exactly. That's what I wanted. There we go. Okay, cool. And I'm going to jump back to chat because I haven't been paying attention to it. Let's see. Oh, this just looks like people talking to each other, it looks like. Okay, so it looks like...
Boy howdy, it's Eric.
Boy howdy, it's Eric. We got an Eric in the chat. Yeehaw.
I am here.
Oh, wait.
Wait, Eric has a mic?
Eric has a mic?
What?
Mm-hmm.
What?
Where's
Eric.
that from?
Eric! Where did you get a mic from? For those of you who aren't familiar, Eric hasn't had a mic in a hot minute.
Yeah.
Grant, I can't believe you explained the entirety of how a CPU works to me, and I wrote an entire paper on it, and I still don't understand what you're doing.
Hey, don't worry.
Yeah.
If you become a computer engineer, you'll understand within a year. So.
Okay, good, because that's the plan.
You got this. Okay, so where was I? I'm completely off topic. Okay, so we can now parse operands successfully with the commas in it. We can parse immediate instructions. We can parse non-immediate instructions. Is there anything else I need to do in here right now? I don't think so. Okay, I'm actually not gonna... I'm gonna just assume people have perfect syntax for now, because I don't want to crowd things up too much. So let's just try some more. Div R1, R2, R3, mul R1, R2, actually R5, R6, and R7. And then I think that covers everything. We'll do div R1, 100. Okay. that looks to be extracting properly. Yura, yeah, I am absolutely sure you can still fail at understanding ASM even though you graduated from it. Oh, no, absolutely. There are parts where you look at assembly and you're just like, oh god. But on the bright side, the majority of what I do in school is with assembly, so I'm very familiar with it now. But there are certainly different architectures where you jump in and they have some sort, especially in CISC. If you're familiar with CISC systems, it gets real messy real fast. So, I don't know if I'm stupid, but I don't understand how the move function works. Is it just writing to the registers? The move function is pretty much the simplest instruction, and what it does is it basically generates a value of 100 in this case, and it moves that value of 100 to register 1. So it's basically just putting a value in a register. It's like assigning a variable. Or we could also say move R2, R1, which will basically take the value from R1, in this case that's 100 from our first line, and it will move it to register 2. It'll plug that value into register 2. So basically what we're saying here is the equivalent of R1 equals 100, and then R2 equals R1. The move operand is basically just an equal sign. That's basically all it is, right? And we're just assigning things. So it's fairly simple, fairly straightforward to understand.
Well, I'm gonna hop on out.
Okay, see you, Barndles. Thanks for joining me for a little bit.
ya.
Now it's just me and Eric.
Oh, baby.
Alright, Tavi says, who gets to join you in Discord chat? Really, it's just the trusted people, because they're predictable. It's the general move for all of my streams, just because we've had some crazy people join in voice chat. I'm sure you aren't bad. I see you sitting in stream voice right now, but yeah, we've had some people in the past get in here and just be absolutely crazy. So I'd like to avoid that. So here we go. We're now extracting the operands from these instructions. Oh, great. And we index out of range. So this should work, but it's not. Oh, that's because I have 2 lines of empty space. Yeah, there we go. Okay. I should probably make a dictionary of valid instructions, or a list of valid instructions by their code here. So that way I can validate that an instruction is a valid instruction before doing anything with it. So Don is 1. Oops, not Don. 0. Move is 1. Add is 1. Subtract is 1. Multiply is 1. Divide is 1. And is 1. Actually, we'll just do these for now. So def is valid instruction, and then we pass in an operator, and we return instruction list dot we'll return operator in instruction list. There we go. Okay. Tells us if an instruction, or if if an instruction is valid. Or no, we'll say an operator is valid, because we need to be more clear here. Instruction is the full line, and operator is just the first part of the line. So before we do anything in all of these, we should say if valid operator, if is valid. Oh wait, if ASMU, oh, I don't have ASMU in here. Import ASM utils as ASMU, and I'm gonna rename this to ASMI. Now we just need ASMR. There we go. Is valid operator, operator. So we only run this code if we have a valid operator, otherwise we ignore the line, which we can do more with later, but for now, that's the important part, and that seems to work. Okay. So if I put in something like, haha, donut, dog, hat, monkey, yes, that will just ignore that. Perfect. So it ignores these. Not exactly what we want to be doing here, but, or maybe we should say else if line does not equal is not empty, or here we say len line equals 0, because that will be what? Oh, len line 0, or we can say line, the first character in the line is a £sign for a comment. So if not one of these cases, then we raise syntax error, and we can say unrecognized in operator, and then follow that up with oh wait, the operator is already going to be a string. There we go. Okay, like that. Okay, so if not blank line or comment, then we should be able to do things like comment and then run this still. No, okay, that still doesn't work. Oh, here we can say if is space. That looks like it's in the string package or string module. Wait, how do I? Is space Python. String.is space. Oh, if line.is space, that's what it is. Okay. Nope, we're still getting an issue here. Oh, I see, because we're trying to get the operator from something that doesn't exist. So then maybe we should say this. So get the operator for in here. So maybe we should check first to see if line.is space or the first character is that, and then we can do nothing. Oh man, but okay, so that works, but I need to find a better way to handle this. Do you still need to imagine block diagrams in your head to write ASM? No, I stopped I stopped doing that a while ago. It's pretty straightforward for me now. I can just imagine the process as I'm doing it. But it does help me to write out things in pseudocode before I actually jump through and start doing things. Okay, so... Man, assemblers are a lot harder than I would have thought they would be. Yeah, writing programming stuff on stream is a lot harder than I thought it might be. I might not do this again. Tabby says, yeah, parsing sucks. You know it. It's absolutely horrible. It's not a fun task to have to take care of, especially on stream. So maybe I'll get this working, and then I'll stream my my process of actually testing this. What other functions do you hope to add to the assembler? Well, first things first, I got to get all of my instructions actually parsable, and then I got to turn those into machine code. So I have to actually do some binary file assembling with Python once I have my files figured out here, and then I have to write that to an image texture, which is then loaded into Blender and then can be executed properly. But first I have to parse everything, which is not a fun task to take care of. In fact, I kind of hope that in this stream, I said I was going to do it for about 2 hours, so we're coming up on the 2-hour mark in a little bit here. Beskamir says all you need is move, all their instructions are redundant. Or NAND. NAND works as well too. Alright, well, we're detecting white space. Maybe I'll just again assume that we aren't going to have any white space for now. Which is not what we're going to have in the end. But it might be a good way to temporarily hold things over until I can put my mind to this and put together a more formalized plan, because I'm realizing I kind of jumped into this a little bit unprepared, which happens sometimes. Ideally it doesn't though, so I kind of wish I would have thought this out a little bit more. Okay, and then we need to go back to my assembly here and get rid of this extra stuff as well as my comment here. Okay, so we know those work. So now, what's my next step? I get back when I call this. I get the operands back. So I don't need to actually compute anything with these operands. I just need to make sure that everything here can be compiled into a binary file. Oh, you know what? I need to parse the opcode. That's something that I need to do. So let's see here. So instead of doing this, I should have done a dictionary here with the strings being the keys and their values being the opcodes here. Can you do hexadecimal? Oh, you can. That's really nice. I do not mind that one bit, Python. Thank you for letting me do that. So basically, for those of you who aren't familiar with opcodes precede an instruction, and opcodes basically tell the computer exactly what instruction is going to be actually running. So if I go back and I pull up my instruction, what's with the jazz music, bad jazz? Dude, I don't know. I pulled up copyright-free jazz because I felt jazzy today, and that's what we ended up with. So basically, when we actually compose an instruction into binary, this is what it looks like. This is the bit field, basically. It's 24 bits long, from 0 to 24. The first 5 bits are the opcode, and the opcode, again, tells it what instructions it should be running. Then we have things like RM, RN, RD, or the 12-bit immediate and an RD register. That's Oh, you know what? I don't even need to specify other things. I completely overthought that earlier. I should have this up on my other monitor. But yeah, that is definitely something I should have considered when actually writing this. So basically the opcode just tells the processor exactly what it should be running. So this should be .keys. And also this shouldn't be called instruction list anymore. This should be called instruction opcodes.keys. Okay. And then div is going to be OX05. Okay. So a list of, or a dict of all operators and opcodes that correspond with them. Okay. So then maybe I should say when we parse an immediate command, we should be, or wait, no, those are parse operand, parse immediate. Okay, so we should say, have another thing. So we have parse operand, but we need another function here. That's def parse operator. And actually, no, maybe we should say def get, no, we'll keep my naming convention, parse operator, operator. And that's just going to return the instruction opcodes with using the operator as a key. Gets the opcode for an instruction, or for a given operator. And it's going to return that. Neat. So now that we have that, we can say, so this is going to specifically parse the operands. Oh, shoot. So this is going to parse immediate. It's going to parse non-immediate. And these are meant to be for the operands. So in my instructions here, I feel like before I do anything else, I should say smu.parse operator and pass in, first I should say operator equals tokens 0, right? That's our operator. And then we want to parse that, and then we can say that opcode is equal to that. Oh, but why not put it all in one dictionary? You know, we're repurposing this, some of these functions here. Utils, we're gonna say opcode is going to be, so operator is going to be tokens 0, and then opcode is going to be parse operator, and that's going to give us our opcode, and then we'll add that to our dictionaries like this. And then we'll do the same thing for non-immediate instructions. I think the really important thing here is just getting each instruction into a dictionary. That's kind of like the main task. And then from everything after that, we can kind of just, I don't want to say just like breeze by, but this is like a really important part, is just parsing this stuff, which is why it's taking such a long time. It's a pretty complicated task. But there we go. Now we're seeing that the opcode is 1. Can we be more specific here and say printed in hexadecimal? No, because that would require writing a custom print function. So what if we do something else like add R1, R2, R3. Okay, and it shows our opcode is 2. Add R3, R2, R1, and then sub R1 100. Div R1 200, mol R1, R2, R3. There we go. So here we see all of our different opcodes in action. So we have our first opcode, which is move, our second opcode, and believe it or not, what we actually have right here is already enough to actually start assembling this, because if we look at our our word format here, our instruction word format, the things that we really need are the opcode, some flags, which we can go over it a little bit here, RM, RN, and RD, and then we're pretty much golden. So when it comes down to these extra flags here, I think I'm gonna get the rest of these flags done, and then I'm gonna end the stream, just because I need a little bit to work on this in private, especially because I'm gonna be 10 times more productive in private than I am when I'm trying to explain things on stream, but also because that kind of tackles the first part of this assembler, which is getting those first values in. So when I'm talking about these three flags, I, S, and N, I is an immediate flag, which tells you whether or not an instruction is using an immediate. S is the CPSR update flag, which is kind of vague if you don't know what a CPSR is, but we can just ignore that. A CPSR is a CPSR, right? We'll just say that. And N is the invert flag, which will invert the ALU's output before it gets written back to memory. So we need to figure out where these flags exist in our actual instructions, and they're actually included right after the instruction. Right after the operator. So if we write out mul for our operator, we can follow it with N or S, and that will either negate it or update the CPSR. So if I said mul S, that's going to update the CPSR flag as that executes or whatever. So that CPSR flag should be high for this instruction, or mul N should negate it before it gets written back. And the immediate flag is just dependent on whether or not there is an immediate here. So in this case, we can actually, for our immediate instructions, we should just be able to say that, let's see here, our utils. We should just be able to assume that if it is an immediate right here, then our I flag should be 1, just like that for all of these. And then if we're parsing a non-immediate, our I flag should be 0. So just like that, we already have one of these flags figured out. We have our immediate flag figured out. Now we just need to figure out the other two. So let's go ahead and do that. Actually, I should probably do this as well. Instead of doing this, we should start to eliminate some redundant code here. We're going to add in like a base for our dictionary, and then we can just say down here dot, how do you add something? Dot push? How do you add something to can you not add something to a dictionary? You're kidding me. Oh wait, I just I feel dumb. We can just do this. Just like that. So this allows us to kind of streamline the process a little bit here. Probably should have kept these up. And to simplify and clean up our code a little bit, because that's really important to do when you're working with any large project, especially if you're writing an assembler, because I'm going to have to come back to this on multiple occurrences and update it to do new things. So I want to be able to read my own code. That is marginally important. Okay. Oh wait. That's not right. Oh wait, yeah, that is. Optic. That's a really bad name for this too. I should rename that. Because that just confused me as to what I was actually writing to here. Optic RM. It's going to be that. And additionally, this allows us to make changes to our, our base operation dictionary or whatever. Maybe I should call this instruction dict. So, because that's kind of how that's kind of what purpose that is serving. Start our dictionary with opcode and flags. Does this work still? Cool. All right. So that works. So then we want to do the same thing for our immediate up here. Oh wait, I'll do this after. Okay. Actually, we can even streamline this a little bit more. Let's do that. No, for readability, I'm gonna do this. And then we can once again come down here and say oh wait, this is instruction dictionary now. So instruction dictionary RD. By the way, I don't know if people are sending things in chat. I'm not really paying attention right now, but I will be in a second here. I'm just gonna get this code updated. Look at how much cleaner this already is. Isn't that nice? There we go. Okay, and then this should all work. No, optic reference before assignment. Ah. Okay, I see here. We don't want this. And we want to return instruction dictionary. We don't want this. We want to return instruction dictionary. Okay. There we go. Okay, we're golden again. So let me look at chat again. I don't think anybody's sent anything. Yeah, chat's dead. I figured. There's not much to talk about when you just see a guy programming. Ooh, Brian Wilson says, good day. Hello, Brian. How are you today? Hopefully you're doing well. Okay. So now we have our opcode, our immediate flag, RD, and IMM. So let's dive into this a little bit further. I need to get the N flag and the S flag out of here as well. So those are two things I have to parse out of here. So what really is important here is the valid operator thing. Right now what this is doing to check if something's a valid operator is it's just checking it against the keys in the dictionary to see if it's included in this list of keys. We don't necessarily want that, because what if we have an instruction that says move S? Move S isn't going to be in our list of opcodes. So really what we want to say is that the first 3 characters are in there, which should work here. And then even if I say move S R1 100 here, we should get we get unknown, probably because why did we get unknown? I know why we get unknown, but I don't know why we get unknown, because we're using a switch. So really what we should be saying is operator. You know what, instead of doing this, how about this? We check the full operator here, but when we pass it in here, we pass in the first 3 characters. Or is that... Beskim, you're literally just here for jazz and a calm narration voice to serve as background noise. Yeah, I do that too when I'm working on papers. It's kind of nice. Oh, okay. That's not going to work either. Okay. So what's the plan here? Or maybe this is the plan. I feel like, okay. I feel like I should just be able to pass in the token here because this is at a very high level. I want to specialize in this area. So we should check that it's a valid operator here. But I feel like in here as well, we have to do some sort of checking. Maybe we'll say, I'm not sure how I want to approach this. So basically what I'm trying to do here is I'm trying to get the first 3 characters out of it and only consider the first 3 characters. And there's a million ways to do that. But I'm trying to figure out where I want to do that such that it's most fluent with my code, or helps my code flow more successfully here. I'm really not sure where I want to jump in on that. It might be worth making a distinction between operation and mnemonic. That's a good point, an operation and a mnemonic. That's a good idea. That's a good idea. So maybe the operation is, or the operator is the full thing. So if we have something like DONS, that's the operator, but DON is the mnemonic. That's a good idea. That's a really good idea, Tavi. Thank you for giving me a word to use for that shorter portion of it. So I guess we can say then that the mnemonic is that how you spell that? Yeah. This is going to be a pain to type out every single time, but is just going to be the first 3 characters of the operator. All right. And so then we switch on our mnemonic instead. Get mnemonic. Okay. And then what did I refer to these things as? Immediate flag. I guess I could just say flags. Okay, and then we're just gonna say I didn't really need to put this on multiple lines either. So So what I'm doing now is I'm basically just checking to make sure that all of the mnemonics, or that the mnemonic is valid, and also the flags that come after the mnemonic are also valid. This doesn't seem right though. Oh. Okay. Okay, so basically what this should do is it should parse the mnemonic, then it should parse the flags and add them to a list, and then check if mnemonic is valid. Mnemonic is valid, and then check if flags are valid. And then we return true if both of those cases are true. So both of those, it both has to have valid flags and valid other stuff, but of course we're gonna get issues. So let's see how this works with nothing. Okay, so let's try this with a really simple scenario, move S. And we get an issue in parse operator right here. So it gets the off code. Ah, okay, so that worked. So that recognized S. What if I do like move Q? Unrecognized operator. Okay, there we go. Move S. We'll get to the next step. Move N. We'll get to the next step. Move NS. We'll get to the next step. Move SN. We'll get to the next step. But move Jeff will not. What about move SQ? Perfect. Okay, that works. So then we need to make sure that maybe I should be more specific here. So it gets the opcode for a given mnemonic, and then this should be parse mnemonic. Okay, and this takes a mnemonic and checks to see if the opcode exists for the mnemonic. Okay, and this gets called by these, right? No, what parses the mnemonic? The mnemonic. Okay. Maybe I should have another function here called def, or gets the mnemonic from an operator. So def get mnemonic operator, return operator up to 3, basically. So that's going to be useful here. Get mnemonic. So ASMU get mnemonic from the operator. And then in the actual instructions here, we want to do something with it. What do I want to do with it? Oh, I want to do it in ASM utils. So here we want to say opcode is parse mnemonic, and then we want to get the mnemonic is going to be get mnemonic from the operator. There we go. Okay, and then I can throw that down here as well. Which is partially making me think I should have one set of code for both of these, but I don't know. Ah! Okay, so we move. And this should raise an exception. This should not raise an exception. This should not raise an exception. Cool. All right. Okay, so what are people saying here? Okay. Nothing really other than what we were talking about before. Actually, no. Yeah, okay. So then I should have another thing that says get flags. So def get flags operator. That should do this. Okay. Let's just check this one more time to make sure it works. Okay, cool. So then when we get down here, we have an immediate flag, but then we can also say that flags. So here, wait. Maybe we should do this. So split the operator into a mnemonic and flags. And then once we do this, then we can get the opcode. There we go. Okay, so we want to do this down here too. And then down here we can say that n is going to be flags dot, oh wait. Or what can we say here? We can say n in flags. And then s is going to be s in flags. Is this really how this works? Is this really Python? Python is ridiculous, man. What do I have first? Do I have n or s first? SN. I have s first. Probably follow my conventions then. Python's frickin' ridiculous, man. Boom. Although, oh, those should be bools. Okay, that's a good call, Python. I didn't even mean to make you do that. I forgot booleans existed completely in Python. Where's immediate? So this should be true. Okay. So immediate true, s false, n true, because move n. And then if we do move s is true, n is false. You know, I almost feel tempted to actually turn this into integers. Can you cast a boolean to an integer? I hope you can. Yeah, okay, cool. I'm gonna turn these into integers because if I'm looking at these as bools, they're gonna destroy my brain. So this should be 1. And down here, this should be int. Int. And this should be 0. Okay, that's so much easier for me to look at. So we have our opcode is 1. We are using an immediate. We are updating the CPSR. We aren't using the negate flag. Our destination register is 1 and our immediate is 100. Cool. Okay, maybe let's try another one. Move SN. Cool. So let's try this. Move R1, R2. Move S. Let's actually do this. Move S, R1, R2. Move N, R1, R2, R2. Thank you. Move SN, R1, R2. There we go. So I0, S0. Maybe we should do this the other way around though. No, that's right. Yeah, okay. And then if we wanted to do an immediate now, we could copy all these again and replace R2 with 100. And do the same thing. Uh-oh. Oh, right, because I have a blank line. Yeah. Okay. Well. Let's try a different format. That works. Cool. Well, ladies and gentlemen, we are successfully parsing data, it looks like, which means that now that I have this working, I just have to add some additional safeguards and add support for the rest of the instructions. But I think we might be functional here. Says, if you think Python is ridiculous, you'll never want to touch Java or even C#. Dude, I actually prefer Java and C# to Python, because at least they have like data types and they have a root in C, because I'm very familiar with the whole C lineup. So Java and C# for me aren't nearly as bad as Python. Python throws me off though, mainly because of no data types. That's the main key. But anyway, I think I'm gonna call it quits with this. I was only gonna do this for about an hour or so, or sorry, 2 hours or so, but I went a little bit over that because I couldn't figure this out. But we've successfully went ahead and parsed our first few instructions. Now all I need to do from here is actually take this information and turn it into binary data that can then be written to my my image files. So it's a task and a challenge, but you know, it's gonna be something to do. Eric, what do you think?
You got a lot on your plate there.
Yeah, that's pretty much how I feel.
A while ago, I took one look at C++ and I was just like, I'm done. I can't.
Yeah.
It's C++ is so different from literally everything else I've ever
Oh,
seen.
C++ is syntactically just a mess, but I am excited. I haven't learned C++ formally yet. I know little bits and pieces of it, especially because I know C, but we're still working on that, so. But anyway, for those of you who are still watching and stuck around for almost the entire stream, thank you for watching. Be sure to stay tuned in the future. I'll be doing more with BARNDLES as time goes on and as I figure out more and more stuff. But other than that, I'm going to call the stream quits for now. Eric, do you have any final words for everybody on stream since you finally have a mic?
No.
All right.
I don't.
Well, we'll end it. Your final words are I don't. We'll leave it with that. All right.
Those are good final words.
Those are good final words. All right. Thank you all for watching, and thank you all for sticking around. I hope you have a wonderful night or day wherever you are located in the world, and I'll see you guys around. See ya.